Hello students. Now moving further, in this video we will discuss about the solutions to the practice questions given as of now. Here we have first question in which we have to find the minimum length of the mirror required to see the full image of the wall by the observer. Now let's first develop the image of the wall, and as here we can see that the wall is at a distance of 2L from the mirror, hence the image will also be formed at a distance of 2L. Now in this case, for observer to see the full image of the wall, there must be incident rays from the observer which after reflection will reach the top and bottom of the wall. Here we have first incident ray which after reflection is reaching the top of the wall, and if I extend this incident ray beyond the mirror, then it will reach top of the image too. And here we have second incident ray which after reflection is reaching the bottom of the wall, and if I extend this incident ray, then it will reach the bottom of the image too. Hence, the length of the mirror in between these two incident rays will be the length of the mirror required to see the full image of the wall by the observer. Now let's drop a perpendicular from the observer to the mirror and extend it to the image. Here we can see that as the observer height is h by 2 and the wall is of height h, hence this perpendicular dropped from the mirror will be at a height of h by 2. The image will also be parallel to the mirror, hence this height here will also be h by 2. Now let's mark some point. Here we have point P where the first incident ray is interacting with the mirror, point Q where the second incident ray is interacting with the mirror, point M where the normal meets the mirror, and point A is the top of the image, point B the bottom of the image, and point N where this normal from the observer is reaching the image. Also, let's say O is the point of observation. Now in this figure, if I see the triangles OPM, this triangle, and this bigger triangle OAN, then here we have in these two triangles angle POM equal to angle OAN, which will be common between both these triangles, angle OMP equal to angle ONA, which will be 90 degree, and angle OPM equal to angle OAN, which is the angle formed between two parallel lines. Hence, we have triangle OPN congruent to triangle OAN. Hence, we can write that this length PM over here upon this length AN over here, the ratio of these two lengths will be equal to the ratio of lengths OM and ON. Hence, we can write this equation as PM upon h by 2 equal to L upon 3L. From here, we can find PM as equal to h by 6. Similarly, using bottom two triangle, we can get QM equal to h by 6. Hence, the total length of the mirror required to see the full image of the wall by the observer will be equal to PM plus QM. Hence, 2h by 6 or h by 3. Now in the second question, we have to calculate the minimum length of the mirror so that the child can see his image as well as his father's image. Now first, let's form the image of the father. As the father is at a distance of 2L from the mirror, hence this image will be formed at a distance of 2L. Now in this case, as in the previous problem, for child to see the image of the father, there must be incident rays from the child that after reflection will meet the top of the father and the bottom of the father. Also, extending these two incident rays beyond the mirror will reach the top and bottom of the image. Hence, this length over here will be the length of the mirror required to see the full image of the father. Now in this case too, let's drop a perpendicular from the child to the mirror reaching the image, and here this height will also be h and this height here will also be h, as the mirror is parallel to the child and the image form will also be parallel to the child. Now let's mark some point over here. Point O is the point of observation, point P where the first incident ray meets the mirror, point Q where the second incident ray meets the mirror, point M where perpendicular meets the mirror, point A is the top of the image, point B is the bottom of the image, and point N where the perpendicular meets the image. Now in this figure 2, if I take these two triangles, triangle OPM and triangle OAN, bigger triangle, then here we have angle POM equal to angle AON, angle OMP equal to angle ONA, and angle OPM equal to angle OAN. Hence, these two triangles will be congruent, and I can write PM upon AN, that is this length over this length, as equal to this length ON upon this length ON. I can write Pm upon h equal to L upon 3L, and solving this I can get Pm as equal to h by 3, and similarly we can get Qm equal to h by 3 too. Hence total length of the mirror required for child to see the image of the father will be equal to Pm plus Qm, that is 2h by 3. Now for child to see his own image, let's form an image of the child. Also this image will be formed at a length L, and for child to see his own image, there must be incident rays from the child which after reflection will reach the top of the child and bottom of the child, and extending these incident ray will reach the top of the image and the bottom of the image. Now in this figure, here we have the length of the mirror required so that the child can see his own image. Let's mark some point over here. Point O is the point of observation, point P where first incident ray meets the mirror, point Q where second incident ray meets the mirror, point A is the top of the image, and point B is the bottom of the image. Now in this figure, if I see triangle OPQ and the bigger triangle OAB, then we have angle POQ equal to angle OAB, angle OQP equal to angle OBA, and angle OPQ equal to angle OAB. Hence these two triangles will be congruent, and I can write PQ upon this length AB over here equal to OP upon this length OA over here, or I can write PQ upon H equal to L upon 2L, or PQ will be equal to H by 2. Hence the length of the mirror required for child to see his own image is equal to PQ, that is h by 2. Now in this case, for child to see the image of the father, the length of the mirror required above this perpendicular is h by 3, and below this perpendicular is also h by 3, and to see his own image, the length of the mirror required below this perpendicular is h by 2. As in this case, the first ray that is incident on the mirror that will after reflection reach the top of the mirror will be perpendicular to the mirror. Also here in this case, we can see that the length of the mirror below this perpendicular is overlapping. Also h by 2 will be greater than h by 3. Hence the total length of the mirror required so that the child can see his father's image as well as his own image will be equal to h by 2 plus h by 3, that is 5h by 6. Now in the next question, we have to find the total number of images formed and their distances from the mirror. Here this figure is given. Now in this figure, let's drop incident ray from object on mirror M1 and M2. Here we have incident ray and reflected ray from M1. Here we have incident ray and reflected ray from mirror M2. Hence in this case, as no length of the mirror is overlapping, hence the reflected ray from one mirror will never reach the other mirror. Hence there are no multiple reflections. So there will be one image formed from mirror M1 and one image formed from mirror M2, and from M1 the image will be formed somewhere over here. Let's call this image I1, and from M2 the image will be formed somewhere over here. Let's call this image I2, and the I1 will be formed at a distance of 2 mm to the left of M1, and I2 will be formed at a distance of 8 mm to the right of M2, and the total number of images formed will be only 2. Now in the next question, we have to find the total number of images formed and their distances from the mirrors. Here it is given that the mirrors are inclined at right angle and the object is placed over here. Now in this case, the first image formed from M1 will be at a distance of 10 mm from M1 and at a distance of 20 mm from M2, and the image formed from M2 mirror will be at a distance of 20 mm from M2 mirror and 10 mm from M1 mirror, and the image 1 and image 2 will both form image from M2 and M1 mirror respectively, and the image formed will overlap and it will be at a distance of 20 mm from mirror M2 and 10 mm from mirror M1. Hence the total number of images formed over here will be equal to 3. Now in the next question, we have to find the total number of images and the location of images from both the mirrors and the location of these images from M2 mirror in anti-clockwise direction. Here it is given that the mirrors are inclined at 120 degree and the object is placed at an inclination of 105 degree from mirror M1. Now in this case, let's first calculate 360 by theta, and it will come equal to 3, which is odd, and also the object is placed unsymmetrically between the mirrors. Hence the total number of images will be 360 by theta, that is 3. Now let's use the table to get the inclination of images. The first image from M1 mirror will be formed at an inclination of 105 degrees, and from M2 it will be formed at 15 degrees. Now the next image from M1 mirror will be formed at an angle of 15 plus 120, that is 135 degrees. These three will be the final images formed. Now to get the image angle from M2 in anti-clockwise direction, here we can see in this figure that the image from M2 is formed in clockwise direction. Hence, to get this image in anti-clockwise direction, let's subtract 15 degrees from 360 degrees. Here we have 345 degrees as anti-clockwise inclination of this image from mirror M2. And from M1 all the images will be formed in anti-clockwise direction. Hence, we have to add this 120 degree to get these images angle in anti-clockwise direction from mirror M2. And here we have image angle as 225 degree and 255 degrees. Hence, arranging these increasing order, here we have first image angle at 225 degrees, the second at 255 degrees, and third at 345 degrees. Now in the next question, we have to find the distance of point P from A such that the ray of light will hit the wall AB at midpoint. Also, there are something that was missing when I previously discussed this question, and it is that the source is located at one of the edges of the mirror and there is only one reflection from M2 mirror and only one reflection from M1 mirror. If these two conditions are not given, then the data given is not sufficient to solve this problem. Now let's solve this problem. Here we have source placed at one of the edge of the mirror. The first incident ray from this source meets the M2 and then this reflected ray reaches M1, and from that this reflected ray reaches to point Q on wall AB, which is the midpoint of AB. Also here this point is point P where the ray meets the M1 mirror. Now let's say that this PA distance is x mm. Also, as Q is the midpoint, hence we have AQ as equal to 3 mm. Also here this distance will be equal to 10 minus x mm. Now let's say that the first angle of incidence here is theta. Then the angle of reflection for this incident ray will also be theta. Also, this angle over here will be theta 2, as these will be vertically opposite angles, and this angle over here will also be theta, as it is the angle of reflection for this incident ray. Now, as these two angles are equal, theta and theta, hence this length over here will be half of this length 10 minus x. Hence this will be 10 minus x by 2. Also here, this angle will be theta 2, as this will be vertically opposite angle. Now calculating theta from this triangle, we have tan theta equal to x by 3. And calculating theta from this triangle, we have tan theta equal to 10 minus x by 2 upon 6. Hence x by 3 will be equal to 10 minus x upon 2 upon 6. And solving this, we can get as x equal to 2 mm. Hence, the distance of point P from point A will be equal to 2 mm. Now in the next question, we have to find the length of bright path on wall AB. Here, if I take incident ray on edge I of the mirror, then the reflected ray will meet the wall AB, let's say at point P. And if I take the incident ray on edge J of the mirror, then the reflected ray will meet the wall AB, let's say at point Q. Hence, PQ here will be the bright spot produced by the light source on wall AB, or PQ is the length of the bright path on wall AB. Here we have the light source located at a distance x from edge I of the mirror, and the first incident ray is incident on this edge I, hence P will be at a distance of x units from this edge I of the mirror. Similarly, as the edge J is at a distance of x plus L from the source, hence point Q will be at a distance of x plus L from this edge J of the mirror. Also, let's say that this point here is M. Hence, PQ will be equal to MQ plus MP. Here, MQ is equal to x plus L and MP will be equal to this length L minus this length x. Hence, PQ is equal to x plus L plus L minus x, or equal to 2L. Hence, the length of bright path on wall AB will be equal to 2L. Now in the next question, we have to find the length of bright path on wall AB, and it is given that the wall AB is at a distance of z units from edge J of the mirror. Now in this case, let's take an incident ray on edge I of the mirror, and the reflected ray in this case will not reach the wall AB. And taking incident ray on edge J of the mirror, let's say the reflected ray will meet the wall AB at point P. Also, there must be incident rays in between these two incident rays such that they will reach wall AB at all other points between point A and point P. Hence, PA here is the length of bright path on wall AB, and the edge J is at a distance of L plus X from light source. Hence, point P will be at a distance of X plus L units from edge J of the mirror. Hence, PA will be equal to X plus L minus J units in this case, and the length of bright path on wall AB will be equal to X plus L minus Z. Now, if in this case it is given that the length L is less than distance X and L plus Z is equal to X, then figure will look something like this. Here we have L plus Z as equal to X and L less than X. Now taking incident ray on edge I of the mirror, we have reflected ray reaching the point A of the wall as L plus Z is equal to X, and taking incident ray on edge J of the mirror, we have reflected ray reaching the wall AB, let's say at point P. Here in this, the edge J is at a distance of L plus X from the light source. Hence, point P will be at a distance of X plus L units from edge J of the mirror, and PA will be the length of bright path produced on wall AB, and PA in this case will be equal to X plus L minus Z units, and Z here will be equal to X minus L from this equation. Hence, PA is equal to X plus L minus X minus L, or equal to 2L. Hence, the length of bright path produced on wall AB in this case will be equal to 2L. And taking another case for the same problem, here if we have length L less than distance X, and it is also given that the L plus Z is also less than distance X unit. Hence, the figure will look something like this in this case. Now taking incident ray on edge I of the mirror, we have the reflected ray, let's say meeting the wall AB at point P. Also, edge I is at a distance of X from the source. Hence, this point P will be at a distance of X units from edge I of the mirror. And let's say this point P is further A units away from distance Z from edge J of the mirror. Also, taking incident ray on edge J of the mirror, we have reflected ray meeting the wall AB, let's say at point Q. Also in this case, as the edge J of the mirror will be at a distance of L plus X units, hence point Q will also be at a distance of X plus L units from edge J of the mirror. Now in this case, PQ will be the length of bright path produced on wall AB, and PQ will be equal to X plus L minus Z minus A. Also here, A will be equal to X minus L minus Z, or X minus L plus Z. Hence, PQ is equal to X plus L minus Z minus X minus L minus Z, and it will come equal to 2L in this case too. Hence, the length of bright path on wall AB will be equal to 2L. Hello students, thanks for watching our video, and please leave your comments, queries and questions in the comment section below. Also, if you do like our video, then please do subscribe to our channel to be regularly updated with the latest uploaded videos. Thanks.